Okay, hello there, grade 10s. This is the video for Unit 3, Lesson 1, your very first lesson of Foundations 10. We are going to be going over something called factors and multiples of natural numbers. Okay, that sounds complicated and scary. It's really not, okay? Natural numbers are just numbers that aren't negative, essentially. Okay, so we're going to be dealing with no negative numbers today, only positive numbers, and there's not going to be any decimals or fractions. So we're only going to be dealing with whole numbers that are positive. And what we're going to be looking at are their factors and their multiples. So the first thing I have here are some definitions. So we're going to start with the definition of a factor or factors. And factors are numbers that respond to a multiplication. Okay, so what that means is, if I want you to determine the factors of 24, we have to think of all of the numbers that respond to the multiplication of 24. So we have to think of all of the ways that we can multiply two numbers together and get 24 as the result. So what I typically recommend students do is to create a T-chart. So there's our T-chart, and we write 24 at the top. Now we think of one way to multiply for 24. Now the easiest possible way to multiply for 24 is 1 times 24. That's pretty obvious. Okay, so you can see on the left-hand side I put the 1, and on the right-hand side I put the 24. Then what I'm going to do is I'm going to ask myself, what comes after 1? Well, 2. Now, can I divide 24 by 2? Or another way of thinking about it is 2 times what gives me 24? If you want to figure out if 2 goes into 24, all you do is you take your calculator, you go 24, you divide it by 2, and you'll get an answer of 12. So that tells us that 2 times 12 gives us 24. So we know that on the right-hand side of this T-chart, we can write a 12. Okay, there you go. 2 times 12 is 24. Then we keep going down the list. Now we're going to start with 3. Okay, can 3 go into 24? Or is there a number that if I multiply it to 3, I get 24? If you want to confirm, you take your calculator, you go 24 divided by 3, and you'll get 8. You get a nice whole number. So that tells us that 3 times 8 equals 24, and that works out. So we're going to write 8 on the other side. Then we go to the next one, which is 4, and we ask ourselves, can 4 go into 24? And if you do this process again, 24 divided by 4, you'll get 6. So yes, that tells us that 4 times 6 equals 24, and we found another set. Now, I'm just going to erase this to make some space. The next number down after 4 would be 5. If you ask yourself, can 5 go into 24? You go 24 divided by 5, and you'll get a decimal. You won't get a nice pretty number. So that tells us no, 5 does not go into 24. There's no way we can go 5 times something and get 24. So we will not include 5. Okay? After 5 comes 6. But look it, we already have a 6. So we've already taken care of 6. So once you get to a number that you've already written down, that's when you know you're done. You have found all of the numbers. Okay, so there are 4 ways to multiply and get 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. There are 4 ways to multiply for 24. And what we just found the factors of 24. So if I ask you, what are the factors of 24? So I'm answering the question here. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So all you do, if I'm asking you for the factors of 24, you figure out all of the ways to multiply for 24. We get 4 ways, so therefore we found 8 factors. These are called the factors of 24. So you just list them in order, smallest to biggest, and there you go. we know those numbers are factors of 24. They can all go in or divide into 24 nicely. Okay, we're going to do the same thing, but with 41. So what you do is you always start with the easy one, 1 times 41. Then you go down to the next number after 1, which is 2. Now, a little trick here. 2 can only go into an even number. So if you have an even number, like we did up here with 24, you know that 2 will go into it. But once you have an odd number, you know that 2 cannot divide into 41. And you can check on your calculator. You can go 41 divided by 2, and again, you'll get a decimal. We don't want decimals, so we know 2 won't work. Okay, so I'm going to erase that. Then you can go to 3. If you take your calculator and go 41 divided by 3, you also get a decimal. Doesn't work. I'll teach you a little trick to figure out if a number can be divided by 3 or not. All you do is you go 4 plus 1. So you add together the digits of 41. 4 plus 1 equals 5. Can 3 go into 5? Is 3 a factor of 5? No, it's not. So we know that 3 also won't go into 41. Okay, or you can just use your calculator and do it that way. Does 4 go into 41? Well, no, 4 is like 2. It can only go into an even number. So because 41 is not even, it can't go in. 5. Well, for a 5 to be able to go into a number, it has to end in a 0 or a 5, right? I'll repeat that. For 5 to be able to go in or divide nicely into a big number, that big number has to end in a 0 or a 5. If a number ends with a 0 or a 5, you know that 5 will be able to go into it. Well, because it ends in a 1, 41, we know 5 won't work. 6 won't work. 7 won't work. 8 won't work. 9 won't work. 10 won't work. 11 won't work, and so on. There is literally no other option to to multiply 2 numbers together and get 41. We call this type of number a prime number. So a prime number is a number that the only way to multiply for it is 1 times itself. Okay, now if you were in my classroom right now, you would see that I have a giant poster with all of the prime numbers on it up to like 200. Okay, so you would see that on that poster is 41, and then that would be a way of you knowing, oh, 41 is prime. There's no other way to multiply for it besides 1 times itself. Okay, so if I'm asking you though, what are the factors of 41, we can still list those 2. So the factors of 41 are 1 and 41, the only 2 numbers that go into it. Okay, so those are factors, essentially the numbers that respond to a multiplication. Next, we're going to go with multiples. Oh, sorry. Prime factor. So, excuse me, I just wrote down the actual definition for prime number there, or prime factor. All factors that are prime, meaning no number can divide into them. Okay. Sorry, I'm just going to back up here. A prime number is something like 41. Okay, so 41 is a prime number. But if I ask you for prime factors, that's a little bit different. Okay, prime factors means I want you to find all of the factors first. So like for 24, there was a lot of them. And then once you find those factors, tell me which of them are prime. So I'm going to give you an example of that. Determine the prime factors of 24. So I'm using 24 again because we've already done all of that work. We know for 24, there was 1, 2, 3, 4, 6, 8, 12, and 24. So I just got those numbers from going back up here and getting those factors we found for 24. But for this question, I'm asking you to find only the prime factors. So what you're going to do now is you're going to go through this list and ask yourself which of these numbers are prime, meaning there's no way to multiply and get that number. Okay, So we know that 24 is not prime because there are lots of ways to multiply and get 24. So 24 is not a prime number. Is 12 a prime number? Well, no, because there's tons of ways to multiply and get 12 as well. 1 times 12, 2 times 6, 3 times 4. So 12 is not prime. Is 8 prime? Can you think of a way that we can multiply two numbers together and get 8? Well, yeah, 2 times 4. So that's an option. So 8 is not prime. 6. Can you think of a way to multiply two numbers together and get 6? Well, yeah, there's 2 times 3. So 6 is not prime. 4. Is there a way to multiply two numbers together and get 4? Yeah, 2 times 2. 3. Is there a way to multiply two numbers together and get 3? The only way to multiply two numbers together and get 3 is 1 times itself. So when that's the case, we consider this number to be prime. So we know 3 is prime. Whereas all these other guys, there are multiple ways to multiply two numbers together and get those as the result. 2. Is 2 prime? Can you think of a way to multiply two numbers together and get 2? Well, again, the only option is 1 times itself. When that's the case, we know that that's going to be prime. Okay, and then 1 is, of course, is prime as well because 1 times 1. All right, so the prime factors are 1, 2, 3. Whereas 4, 6, 8, 12, and 24, those are not prime because there are multiple ways to multiply and get those results. Okay, so the prime factors of 24 are those guys that are highlighted there. All right, next. Prime factorization. So this is what we're going to get into next. This is kind of the bulk of the lesson. Prime factorization means to break a number down, completely break it down to its prime factors, and then multiply those prime factors together as powers. Okay, that sounds super complicated. I'll show you an example and you'll realize just how easy it is, okay? So example number 1, for each number given, list its prime factors and write it in the form of prime factorization. So we're doing two things here. First, we're going to list the prime factors, just like we did up here with 24. We found the prime factors to be 1, 2, 3. Okay. And then we're also going to write it in the form of prime factorization, and that's new. We haven't seen that yet. So in order to do this, what we have to do is we're going to create like a tree. So I'm just going to zoom in here for 3300. We're going to create a tree. And what we do is we start with asking, what is a way to multiply two numbers together and get 3300? 3300 is a huge number. There are tons of ways to multiply two numbers together and get 3300 as the result. You just have to pick any one you want. So for example, because you know it ends in 0, you know you can divide it by 5 or 10. Because it ends in a double 0, you know you can divide it by 100. Because it's an even number, you know you can divide it by 2. So you can start any way you want. I'm going to start with 100. So I'm going to go 3300 divided by 100 on my calculator, and I get 33 as a result. So I know that 33 times 100 gives me 3300. So I've kind of created my first two branches. Then what I do is I start with just one of these numbers. So I'm going to take 33 because it's on the left, and I do it again. So now it's like I'm creating a branch, but with 33. So now I think, what is a way to multiply and get 33? Whenever you have a number that is the same digit repeated, so 33 or 44 or 55 or 66, you always know you can divide it by 11. Okay, so 33 divided by 11 is 3. So I know that 3 times 11 gives me 33. Now, I'm going to do the same thing over here with 100. What is a way to multiply for 100? There are multiple ways. I'm going to go 4 times 25. You can go 10 times 10. You can go 2 times 50. Does not matter, okay? Then what I do is I start over from the left again, and I work with 3. Now, is there a way that I can split 3 up again? The only option to split 3 up again is 1 times 3. Don't write that down. When that's your only option left, you actually don't write it. That's the way that we know that 3 is a prime number. 3 is a prime number because there's no other way to break it down besides 1 times itself. So when that's the case, what you do is you stop and you circle it. Whoops, wrong marker. You stop and you circle it. Circling it means that it's prime. You're done with it. You can't break it down anymore. 11. Is there a way to multiply two numbers together and get 11? No, the only option is 1 times 11, and we don't write that option down. So 11 is also prime. 4. Is there a way to multiply for 4? Yes, there is. 2 times 2. So we write that down. And 25. Is 25 prime? Is there another way to multiply and get 25? There's one other way, 5 times 5. So now with these new numbers, you ask yourself, should I be circling them or should I keep going? Well, 2 is prime. There's no other way to multiply and get 2 besides 1 times 2. So we know we circle it. 5, same thing. The only way to multiply and get 5 is 1 times 5. We don't write that option down. We just circle it in that case. And same with this 5. So now we know we're done because we can't break these numbers down anymore. They're all circled. So we're going to answer the question now. So part 1 of the question was write down the prime factors. So all of these numbers that are circled are factors of 3,300 and they're prime because we circled them. So all you're going to do is you're just going to list them. So our prime factors are 2, 3, 5, and 11. But part 2, this is the new part. Question 2 asks you to write it as prime factorization. And that's what's new here. So prime factorization means we take those factors and write them as powers. So what that means is you take the lowest number, which is 2. You write down 2. Now what you look at, out of the circled numbers, how many 2s are there? Well, there's 2 of them. 1 there and 1 there. So because there's 2 of them, you're going to write an exponent of 2. Move on to the next number, which is 3. There's only 1 3. You can write the 1 if you want, but that's optional. You don't need to write the 1. Then you move on to 5. How many 5s are there? There's 2 of them as well. And finally, 11. There's only 1 11, so you just write 11 down. And then what you do in the end is you multiply, or you write the multiplication symbol in between those numbers. No commas anymore. Commas are only for part 1. When it's part 2, prime factorization, you're going to multiply them together. And if you want to check your work, like you're a student who likes knowing for sure if you got it right, you can punch that into your calculator. So on your calculator, you can go 2 squared times 3 times 5 squared times 11. When you get that result, you should get 3,300 again. And that's how you know you did it right. You got the original number. All right, we're going to do another one. Same thing, but with 2646. So think of a way or use your calculator to try to find a way to think of 2 numbers that multiply for 2,646. Now, really easy way to do it. You know that that number is even, so you know you can divide it by 2. So let's start like that. Let's keep it simple. So 2 times 1323 is what I got on my calculator. I know that 2 is prime, so I'm just going to circle it right off the bat. But 1323 is probably not prime, so let's just try to think of a number that goes into it. We know 2 won't go into it because it's not an even number, so let's try 3. If I divide that guy by 3, I get a nice number. I get 441. So we know that that works. That if you get a decimal, you know it doesn't work. Okay, so I'm going to circle 3 as well because 3 is prime. There's no other way to break that down. So now I'm going with 441. Okay, I know I can't divide it by 2. It's not even. I'm going to try dividing by 3 again. And it works. So 441 can be split into, 3 times 147. 3 gets circled again. Now I go with 147. Okay, I'm going to try, I can't try 2. It's not an even number, so I'm going to try 3 again. 147 divided by 3 equals 49. So 3 times 49. I circled the 3. Now 49, I hope jumps out at you a little bit. 49 is a pretty popular number because it's a perfect square. Okay, if you remember from grade 9, perfect squares, or even grade 7, 8 maybe, perfect squares are numbers that, or is a number that you can multiply something to itself. So 7 times 7, okay? If you go on your calculator, you cannot divide it by 2, you cannot divide it by 3 or 4 or 5 or 6, but you can divide it by 7, and it ends up being 7 times 7. Now, 7 is prime. There is no other way to multiply and get 7 besides 1 times 7. So that's how we know it's prime, and we are done. We've circled everything. So part 1 is just to list the prime factors. So the prime factors we pulled out are 2, 3, and 7. Now the prime factorization is where we kind of tally it all up. So you start with the lowest prime factor, which is 2, and there's only one of them. Then you're going to multiply it to the next, which is 3. And there are 3 of them. 1, 2, 3. Then you go to 7, the last one, and there are 2 of those. And there you go. If you multiply all those back together again, you should get 2,646. And that's how you know you did it right. Okay. What I'm going to suggest you do is actually pause the video right now and try this one on your own. So pause the video, take out a sheet of paper, try to do 1,025, and then start the video again once you're done, and you can listen to me walk through it and see if you did it right. So I'm going to do this one a little bit quicker and not really talk too much because I want you to try doing it on your own. Okay, so you go for it. Okay, so that was a fast one because what I chose to do was I chose to divide 1,025 by 25. When I did that, I got 41. So that tells me that 41 times 25 gives me 1,025. 41 is prime. I chose this example because we already broke down 41 up here and saw that it was prime. Okay, there's no other way to multiply for 41, so I circled it. But for 25, I broke that down to the only possible option, which is 5 times 5, but then I circled those 5s because those are prime. So for part 1, my prime factors are 5 and 41, but then for part 2, prime factorization, that's where I multiply them together and I tally up how many there were of each. So there were 2 5s, so I wrote 5 squared times 41. All right, if you want, you can pause me again and try this one. So I'm just going to do this one quickly as well. So you know you can for sure divide it by 2. So now what I'm doing is I'm taking 743. I know I can't divide it by 2. Doesn't work by 3, doesn't work by 4, doesn't work by 5, doesn't work by 6, doesn't work by 7, doesn't work by 8 or 9 or 10 or let's try 11. I haven't tried 11 yet. Nope. 12, nope. 13, no. 14, no. 15, no. 16, no. 17, no. Let's see. 17, no. 18, no. 19, no. 20, 21, no. 22, 23. I'm skipping even numbers. I know no even number will go into that. And if we keep going up, we're going to find that nothing goes into that number. Okay. If you want, you can even go into Google and Google a list of prime numbers. And there's going to be tons of things that pop up. And so you can look at a list of prime numbers. And if you look at a list of prime numbers, you'll see that 743 is on there. Okay. So you can also just try a few numbers, but if quite a few aren't working and you think, oh, this might be prime, just Google a list of prime numbers, see if 743 is on there. You see that it is, and so you know not to waste your time anymore. There's nothing that can multiply and get 743. So that's kind of a weird question. We only have 2 numbers, So our answer to number 1 is, what are the prime factors? 2 and 743. But then prime factorization means we tally it up. Well, there's only one of each. So this is going to be 2 times 743. Okay, and there's only one of each. We multiply them together, we're done. I would just like to put a little plug in here. I was about to write it in French. Sorry, I teach math in French too, so sometimes I accidentally write things in French or say things in French, my bad. What I want you to write these in is always numerical order. Okay, so I always want you to start with the smallest number, so 2, and then work your way up. I never want to see this. I never want to see it in biggest to smallest, just smallest to biggest. Okay? All right, so that is that. That's the first lesson of Unit 3. I hope it was okay. It's a lot of calculator work. At the bottom here is the Unit 3 Lesson 1 assignment. So if you open that up, you'll see a bunch of questions, and on the back you'll see the solutions. So you pretty much have to do what I did here in these last 4 examples for each question. So I need to see these factor trees. That's what I call them, is factor trees. I need to see this work done for you to get full marks, okay? If you just copy down the back and don't have any factor trees to show, I'm going to assume that you just copied the solution from the back. So show me those factor trees, and as I said in our meeting, you can always send me messages or emails if you have any questions if you're stuck. Okay, good luck.